Designing and building a workbench. Quick, easy, and effective. I don't know about you, but I started off with a table made of sawhorses and a flat surface, a door, etc. These were not stable, they wobbled and moved around when I didn't want them to. Plus, I had no ability to clamp and to hold a workpiece in a vise. I had the tools I needed, but didn't have the ability to rigidly hold workpieces so I could work on them. I needed a workbench. Most woodworkers end up wanting one and then either buy one or make one by copying what they have seen online in various stores. This is natural, however it may not be optimal and they may end up missing key functions, even with commercial workbenches. Also, quite a few workbench plans are so complicated you need a workbench to build them. That's not to mention the expensive hardware and the large arsenal of tools and skills they required. I wanted something easy to build and inexpensive. It did not need to be a fine piece of furniture. I approached this design problem from an engineering point of view. It's okay, I am one. I understood that a workbench is really several simultaneous big clamps holding in a variety of ways. I wanted one because of the need to easily plane, chisel, route, and saw wood held rigidly without movement. But what specifically are the requirements for a workbench, and how do they change based on the type of woodworking you plan to do? As I was researching and defining what was needed, I came across an article that defined most of my needs and laid out the requirements in a well-defined manner. I have seen way too many articles that talk about the process of making a workbench, rather than the why of what is being made. The article I liked was Rules for Workbenches by Christopher Schwartz, November 7, 2007, Popular Woodworking Magazine. I'll list it down below. I have summarized these rules and then applied them to my design and rated how well I met the criteria requirements in italics. Rule number 1, always add mass. The requirements are to be heavy, stout, and immobile with a top that is smooth. A bench that weighs up to 300 pounds and beyond is not going to move. My bench weighs in at excess of 300 pounds, is rock solid with a smooth surface. I've added 3 tool drawers underneath, which when full brings a weight upwards of 400 pounds. Believe me, it won't move. Rule number 2, use stout joints. Overbuild your workbench. Use either through tenons or dovetails, or threaded rods or bolts that achieve the same results in the top and bottom framework. My bench uses threaded rods throughout, and any part of it can be tightened easily or taken apart. It does not move or rack. I wanted to be able to disassemble it since I anticipated a need to move to a different workshop. Most designs require woodworking skills, mortise and tenons, not present in the arsenal of the person building the workbench, nor do you have a workbench yet, which certainly helps. Rule number 3, pick your wood based on its stiffness, not its species. Pick a wood that is stiff, resists denting, and can span long distances without much support structure below it. Resist getting tangled up with the requirements for beech or maple only. Other woods such as white oak, southern yellow pine, and fir will perform fine. For my bench I used Douglas fir and pine door that was 1.5 inches thick, and the surface is smooth, flat, and it does not deflect along its length. Rule number 4, use a tested design. The main idea here is utilizing existing and useful definitions, not reinventing the wheel with unnecessary features or uniqueness. All of the features on my workbench can be found on other proven designs. Rule number 5, the overall dimensions of your bench are critical. Your bench design cannot be too heavy or too long, but its top can easily be too wide or too tall. Mine is 70 inches long and 26 inches wide. The height is 34 inches, which is just right for me, standing with my arm hanging down and my hand folds flat on the top. The thickness is only 1 3/4 inches with a 2.5 inch surround. I chose a heavy, stiff, and perfectly flat wood finish door for the top rather than fabricate a top. Rule number 6, benches must hold the work in 3 ways. All benches should be able to grip the wood so that you can easily work on the faces, the ends, and the edges. Many commercial benches fail on this point. I meet the requirements. My workbench has bench dogs, hold downs, meaning hold fasts, a face vise, and an end face vise, and a dead man for long boards and doors. I can clamp down and hold cabinet doors, long boards, and large and heavy doors. Rule number 7, make your bench friendly to clamps. Your bench is a three-dimensional clamping surface. Anything that interferes with clamping work to your bench top, aprons, a drawer bank, doors, supports, etc., can make some operations a challenge. My workbench meets most of these requirements. The only drawback is the back of the bench where I have a tool trough, where clamping is more difficult. However, I have holdfasts that can be placed anywhere to meet the need. Both vices have bench dog holes to aid clamping. I also have created and invented a mechanism to clamp a board in place, which I'll show in a subsequent slide. Rule number 8. There are good rules for placing the vices on your bench. Classic workbenches have some sort of vise at the front left corner of the bench. This is called the face vise. Why is it on the left? Well, when we work with hand tools, especially planes, right-handers work from right to left. My workbench has a face vise on the front left and a face vise on the right side toward the front. I find this provides me maximum versatility when clamping boards for dovetails, planing on either long or short boards, and using the vise on the right-hand side for any cutting I need to do of iron or steel rods or things of that sort. Rule number 9, no fancy finishes. When finishing a workbench, less is more. My workbench meets the requirement. I just kept the door finish and I put shellac on the balance of the workbench. Rule number 10, get a window seat. Try to place your bench against a wall and under a window, especially if you use hand tools. My workbench is back against a wall. I didn't have a window to put it under. However, the need for good lighting is met. So overall, I would rate my workbench a 9 plus out of 10. Not bad. Certainly it meets all of my needs at present. More important, this exercise should prove useful to you in either designing your own or buying a workbench. This workbench is not my original design. I modified the design of the base support of a Fine Woodworking article entitled Simple Sturdy Workbench from Getting Started in Woodworking, Season 2 by Asa Christiana. I'll put it in the links down below. I used that design for the bottom supports but modified the top. I used a thick solid wooden door rather than MDF and added a thick wood surround, made it longer and easier to clamp, added an additional vise, added dog holes, added a tool trough, added a dead man with peg holes. The Fine Woodworking design uses MDF. I'm not fond of MDF. Very dusty to route. If it ever gets wet, it will distort, plus I wanted a longer top surface of wood. I also identified a much easier building and assembling method. My design eliminates the volume of hardwood typically included in the workbench top and replaces it with an inexpensive and structurally solid, unbending, solid hardwood door. I will show that in subsequent pictures. To complete the picture, consider the normal top. A typical design would be 2.5 inches thick, 7 feet long, and 24 inches wide. Run that through your board foot calculator and you'll find it's 35 board feet. A rough cost of maple is $7 a board foot, so this would cost $245 just for the workbench top. Now clearly maple is not the only choice of wood, but you get my point. My intent was to make a workbench quickly, simply. It's less difficult to use threaded rod than mortise and tenon joints, especially when you don't have a workbench to use to make these joints. Inexpensively, and one that can be used by 2 people at a time taking my woodworking course. But please, if you feel the need to assemble a series of 32 3/4 inch thick boards 7 feet long, glue them, plane them smooth, and need the experience, go for it. I wanted to quickly build a workbench. Here's the spreadsheet which shows the workbench cost. As you can see, the largest item is the heavy-duty vise. I initially had 2 Irwin vices, but the one for the face vise on the front was simply inadequate. The Rockler vise suffers from racking. More expensive vices have solved this problem. I solved it a much easier way, and I'll show that in a subsequent video. So you can see I got paid very little for the top for the door, and the balance of the wood is just 2x4s or 4x4s. Here's an overall SketchUp view, and you can find this SketchUp on my site, my Down East Wood Art site. I'll provide a link below. And you can see that I've just used a door on the top, and underneath it's put together with threaded rod in grooves that tie 4x4s together with tightening provided by the rod as well as the 2x4. So it's an extremely rigid design. Underneath there's plenty of room for drawers, and you can see that I put them in my bench at a later date. Here's an exploded view, again using SketchUp, and this is available on my site, downeastwoodart.com. I'll provide the link below, but it gives you the specific dimensions of all the pieces, including the threaded rod, and gives you an idea of how the whole thing is put together. Yes, it is indeed designed, but now we need to develop a plan to build it. Sometimes the plan for how to build it is obvious. Other times you think of different ways halfway through. What always seems to work better is to spend a little time up front thinking about what to do and in what sequence. I want to lead you through a thought experiments along those lines and get you thinking about time savers and effectiveness contributors. It's clear that we need to cut a number of pieces, but what are we going to assemble all the cut pieces on? How about a workbench? In other words, why not build the bench top first, mount it on a pair of wood sawhorses, and use it to assemble the leg framework? That works for me. Now, what do we need to cut? 4 short 2x4s, 4 longer 2x4s, and 4 leg 4x4s. Once cut the 2x4s, we need to route grooves in the sides or bottoms of each. Then we need to drill 32 holes for all the dowels, 2 for each side stretcher, of which there are 4, 2 for each long stretcher, of which there are 4, and finally a hole in each leg where the stretcher dowel joins. 4 legs with 4 holes in each. Okay, cutting in different ways doesn't seem to gain us much time or accuracy. Alternatives, including cutting with a circular saw and a jig clamped to the 4 stretcher 2x4s versus cutting them individually on a table saw. The easier way I've found is to measure carefully and cut one, then use that as a marking template for all the others. This works well. Now, if you don't have a way to cut perfectly square, a table saw sled would be very useful. Miter gauges are typically not very accurate. You can find any number of articles on the internet which describe how to build one. Just Google table saw sled. We have choices for creating the grooves in the 2x4s. We could cut them with a router or with a table saw and a set of stacked dado blades. Either will work, but I find it easier to use my router in a situation like this. Changing out a set of dado blades takes longer. I have to remove the riving knife, which requires getting at screws in a difficult location. Then changing a router bit, and I usually have a 3/8 inch bit in the router anyway. Also, when done with a dado, I always have to change the blade back to my combination blade. But how about all those holes we need to drill? Now, if we take the conventional approach, we would need to measure each one and locate it prior to drilling. What's an alternative? We must locate and drill the holes, yes, but what is a quicker, more accurate, and a lot easier? Here's where thinking about jigs and fixtures pays off. What if you made a template jig for all those holes, which would preclude measuring each time? You would save time and increase accuracy. The jig could be placed over the workpiece and then used to locate the holes to be drilled for all dowels in legs and stretchers and for all the threaded rods in the legs. A SketchUp picture is shown here. The steps include making and using the jig. It was a great time saver and greatly improved accuracy. So, was this little mental exercise worthwhile? I hope you see the benefits. Try it on your next project. Okay, so now we're going to build the bench top. Take a look at the exploded view of the workbench top. I cut the solid wood door to 68 inches by 24 inches. I used a long straight board clamped to the door to cut it to the width with my circular saw moving against this board. I then ripped 2x4s on my table saw to 1 inch thick and 2.5 inches high. I also built in a small tool tray on the far side by supporting it with the ripped 2x4s and 1/2 inch plywood underneath. All the pieces were glued and screwed to the solid wood door. I also plugged and filled the door handle opening. Once complete, I had a nice solid rigid surface. As you can imagine, this took very little time. The assembled top is shown. Okay, now let's cut the legs and stretchers. Now cut all 4 legs the same length. Mine are 32 and 1/4 inches. Yours may differ. Using a table saw or circular saw, make a 2-pass cut, necessary because of thickness on each leg. Find a way to support your legs on both ends and in the middle near your cut for safety and to reduce tear out. Cut the side and long stretchers, since you are cutting 4 of each, and if you're using a circular saw, you can gang them up and cut all 4 at once. Clamp the legs together, mark your cut line with a square, clamp a straight edge board parallel to the saw, cut the distance of your circular saw base plate away from the cut line. My side stretchers were 16.5 inches and my long stretchers were 37 inches. Make one of the side stretchers an inch longer, 17.5 inches. Once routed, we will cut off 1 inch and turn the cutoff piece into our hole cutting jig. Okay, now it's time to route the slots. Use a router to cut the grooves in the stretchers. You can accomplish this without repeated setup by recognizing the repeating nature of these grooves. Route the bottom groove of the side stretchers. Since there are 4 side stretchers, you can route the bottom groove in all of them without changing your router fence location. Put a 3/8 inch straight cutting bit in your router and set your fence to cut down the middle of the 2x4 bottom. Starts at 9/16 in the edge. Also then take the next step of routing the top groove in all top stretchers. Follow that by routing the side groove in all long stretchers. Finish the hole cutting jig. Take the 17.5 inch side stretcher and cut off an end, leaving it 16.5 inches long. Before making this cut, this jig needs to have another groove routed in it for the long stretchers. Your router fence is set at 7/16 of an inch from the edge, so use that setting and route the remaining groove. Drill the dowel hole next and you have finished your jig. It should look just like the SketchUp graphic. Drill the dowel holes in the stretchers. Cut 16 3-inch pieces of 3/8 inch dowel and drill all 16 holes for the dowels in the stretchers using the jig. Next, mark all the legs with a carpenter's triangle orientation mark. Look carefully at this picture. It's in the upper left-hand side. This helps keep each leg in its correct position while you cut holes for the stretchers. Without this mark, you cannot be certain which face of any leg is the right one for attaching a particular stretcher. Also, mark the top of each bottom stretcher on each leg. Use a square and mark a line 9 3/4 inch up from the bottom of each leg. This reference mark will help you align the bottom stretchers. Review these 3-leg orientation graphics. Just take a minute and look at them in sequence. This sequence represents how to effectively orient and drill the dowel holes and threaded rod holes in each leg. Notice how the jig is positioned on each leg. In the middle, horizontally, either at the top or at the height mark, and always having the slots facing inward toward the other legs. The other thing to remember is to use the bottom slot of the jig to drill threaded rod holes in each legs with the side stretcher connection, and use the jig's lower side slot to drill threaded rod hole in legs without long stretcher connections. To summarize, each leg gets a 4 dowel holes drilled and a 4 threaded rods holes drilled. To drill each hole, position the jig over the leg and use it as a guide to start each drill hole. You can use an awl to mark the center of each hole with the jig in place. Then just remove the jig and drill the holes. Complete all drilling for each leg, one leg at a time. This helps you think about orientation. It is easy to get confused. Think twice before you drill. Finish this process for all 4 legs. Okay, now we're ready to assemble the base. Now tap 4 dowels into each leg. They should tap in easily and leave less than 1.5 inches protruding. The whole purpose of the dowels is alignment of the stretchers. So choose 2 end legs and 2 side stretchers and lay the legs flat on your workbench top. Push and tap the stretcher onto the dowel in the leg. Repeat this process for the other stretchers, then push and tap the other leg into position using the dowel. Now slide the threaded rod through each leg until it emerges from the opposite end. Attach a nut and washer on both ends and tighten both ends. Perform the same steps for the remaining 2 end legs and 2 side stretchers. Now you're ready to tie the assembled ends to the long stretchers. Do this for both sides and upper and lower long stretchers. Again, push and tap the stretchers onto the dowels. Now lift the previously assembled opposite end and tap and push the leg onto all 4 dowels, 1 dowel at a time. This will be a bit cumbersome, but just take one at a time and move the legs a little bit onto the dowel. Work your way around all 4 dowels until nearly tight. Now run the threaded rod through each of the 4 slots it goes through, attach the washers and nuts, and tighten each end. Okay, now attach the bench top to the base. Now lift the top onto the base and position it to leave room for the vise on the left end. Once positioned, use the S-clip type tabletop fasteners to firmly attach the top to the base. Each clip has one end in the top rotted groove of a top stretcher and the other end screwed into the bottom of the workbench top. I use 6 of these clips all around the bottom of the top to ensure no movement. Attaching the vices to the bench. This picture shows the rockler vise. I'm not going to detail the attachment because you may choose to have a different vise. Basically, it's a matter of bolting it to the underside of the bench. Drill the bench stock hole pattern. As you can see above, I drilled a pattern of 3/8 inch holes. This is the standard hole size for the bench dogs and holdfast. I used 3 inches on center front to back and 5 inches on center left to right. This pattern has worked well for a variety of clamping needs. Note the 3 holes in the vise front that make clamping easy. I used a Forstner bit to drill these holes to ensure a nice clean opening. I recommend laying out a pattern that suits your needs. If this is unfamiliar territory, just use mine. Play around with it, add holes as needed. There are no hard and fast rules. You just want to be able to clamp anything you are working on. Installing a dead man. A dead man serves the purpose of holding up the opposite end of a long board, panel, or door, while the other end is in the vise. This mechanism is very handy when you're planing off the edge of a board to make it straight. I cut a 2x4 and used the threaded rod connection to the leg and screwed it into the bottom. Prior to mounting, I drilled 3/4 inch holes approximately 5 inches apart and cut a 3/4 inch dowel to insert into these holes. A little sanding of the dowel end and it inserted in the holes with ease. The photos show how easily and helpful this is to hold a door or a long board in place. Designing and installing drawers. I originally wanted to have a place to mount drawers since I was constantly finding myself with clutter on the workbench top. So drawers were always planned, but as you know, everything in its time, right? Anyway, I finally got around to these and they're shown on the picture. I just used scrap wood, namely 3/4 inch thick plywood for the carcass, and I made 2 that are easily removable. The drawer bottoms were also made of plywood with pine sides, front and back. I used 1/2 inch thick birch plywood for the drawer front and trimmed it with 1/4 inch thick cherry. The drawer side to front connection was dovetailed to add strength. Runners were waxed to make the drawer slide easily, and kickers were added to prevent the drawer from falling down in front when pulling it out. Overall, a satisfying project. I hope yours is as well.